Okay, children, we'll now discuss in detail about the limitation, also called the drawback of Bohr's theory. Okay, the Bohr's theory of hydrogen and hydrogen-like atoms has a number of limitations, also called it has number of drawbacks. Although this theory was successfully explained, especially with the structure of atom, he prepared the model of an atom, and especially his theory was able to explain the emission radiation and about the line spectrum. But as I said, other than this, there are some drawback or limitation that we can observe under Bohr's theory. So one of the drawback or limitation that we can discuss is Bohr's theory explain, if you go through the Bohr's theory explain only the spectra of one electron atoms. Only one electron atom. That means an atom consists only of one electron. And such atoms like hydrogen, yes, we all learn a little about hydrogen atom. And hydrogen isotopes also one atom. Like hydrogen isotope means H1, H1 what? H1, 1, H1 what? 2, H1, 3. These are all the hydrogen isotopes of hydrogen atom. Similarly, it also explains the spectra of what? Helium, ionized helium atom, He plus. Now He plus means how many electron present in the helium atom? Only one electron. The electron present is only one. Because helium basically we write as 2, 4. And 2 is the number of protons. If number of protons 2, then if helium loses one electron, then it becomes what? He plus. That means only one electron present in the helium atom. That is called ionized form of helium atom. Similarly for lithium atom, ionized form lithium atom. That means Bohr's theory, if you go through it, okay, as I said, it explains only the spectra of one electron atoms only. Which means Bohr's theory failed to explain the spectra of multiple electron atoms. Yes, they are the atoms which consist of more than one electron. So Bohr's theory could not make any conclusion, especially with the emission of radiation with multiple atoms. So just writing the point, it fails. Okay, that means Bohr's theory fails to explain okay the spectra, failed to explain the spectra of what atom? Multiple electron atoms. Multiple electron atoms. So this is one of the drawback that we can see under Bohr's theory. Now number 2 drawback is also there. And number 2 drawback basically say that the Bohr's theory does not tell anything about the relative intensities, okay, of spectral line of an atom. Yes, as I have already learned that in case of Bohr's theory, when we measure the spectral, we observe only with the transition. Emission radiation observed only with the different series of hydrogen atom or hydrogen-like atoms. Okay, but whenever the emission of radiation takes place, he could not measure. He has not measured any. He could not make any relation to measure the intensity, the amount of brightness of that radiation which emit from the hydrogen atom. Okay, which means the Bohr's theory completely failed to explain. Bohr's theory does not explain anything about the relative intensity of spectral line of atoms. The lines are obtained. The spectrum are line spectrum. But what is the intensity of the line spectrum? That was not explained by Bohr's theory. Okay, so this is number 2 drawback. Now we have number 3 drawback. And number 3 drawback says that it does not explain the distribution of electrons in different orbit. Yes, as for the Bohr's theory is concerned, as you know, electron revolve in different orbit, definite orbit. Okay, so that, but Bohr's theory could not explain how many electrons are distributed in how many orbits, or in which orbit. Like we know in the first orbit, there are 2 electrons. Second orbit, 8 electrons. But this explanation of how many electron can fit, or maximum electron can remain in the particular orbit, or the distribution of electrons in different orbit was not explained at all by the Bohr's theory. Okay, so this is also one of the drawback that we see in case of, we can observe in Bohr's theory. Okay, now we have a last drawback that I discussed. Okay, and number 4, sorry. And the last limitation of Bohr's theory is actually nothing but it gives no information. That means Bohr's theory has not given any information about the wave nature of electrons. Yes, because when Niels Bohr proposed his Bohr's theory, he completely applied the particle nature of light. okay, the quantum theory of light. Okay, however, the light has what nature also? Wave nature also. Okay, light has what nature? Wave nature. Because we have already learned what light has how many nature? Dual nature, wave nature as well as particle nature. Okay, so when Bohr's theory was made, this theory was made completely on the basis of applying the quantum theory of light or particle nature of light. So, which means Bohr's theory has not given any information about the wave nature of the electrons that makes the emission of what? Radiation. So, these are the four important drawback or limitation that we can observe under Bohr's theory or Bohr's theory. Okay. So, although Bohr was successful in correcting the drawback that was observed in Rutherford, and he made a model of an atom, we consider that model also, but that is also true for certain atoms only, not for all the atoms. Okay, so this makes the limitation of what? Bohr's theory. Now in the next YouTube video, we will be solving some important numericals. So children, the theory part of this chapter is almost done. Okay, so we now solve some important numericals, and that numericals are important for your examination also.